All right, grade 11s. Our next topic is the covalent bond, and sharing means caring. All right, as usual, the iPad is up here in the corner. That has our D2L note, the PowerPoint that I use in class. You can download those notes for free through the class website. As usual, I'll be writing stuff on our whiteboard here as well. And pay attention, because now there are two of the rock telling you, pay attention, jabroni. This stuff's important. Anyway, let's get started. So today we're doing the covalent bonds. If you remember, this is the second part of our trilogy, right? The first part was why we do bonding and what a chemical bond is, and ionic bonds and compounds. This is the second part, pure covalent bonds, how they're made and why they're made. And then the third part will be polar covalent bonds, which will be related to this, but with a slight variation than what we talk about today. So let's get started. So in a covalent bond, two bullies are going to share the toys. Now, from our previous discussion, we know two bullies are going to be two nonmetals, right? The nonmetals are bullies because they have a very high electronegativity. If you remember electronegativity here, it means your ability to grab electrons from somebody else, to fight for electrons when in a chemical bond, right? And if we're talking about two bullies, we're talking about two nonmetals. In the previous lecture, we said that the nonmetals had the highest electronegativity, so they were like the rock here. They're bullies. They're really, really good at fighting for electrons. We said the metals, which seemed odd, the metals were like this guy here. They were the wimpy kid. Their electronegativities were very low. Well, today with covalent bonds, we don't use any of these wimpy metals, so see you later. Oh, that didn't work out very well. Get out of here. All right, so covalent bonds are chemical bonds that hold nonmetals to get together. But this time it's not about beating or stealing, because both of them are bullies and have a very similar strength. One can't clearly beat up the other. The electronegativities are very similar. And so what they have to do is they have to share electrons, all right? They try to fight, but then they realize, man, we're both bullies. I can't beat you. You can't beat me. We need to share, dude, right? Remember, it's all about getting those 8 valence electrons, right? $8 can pay for everything. Well, if you can't beat someone up and steal money, you've got to share and pool your money together. And that's what a covalent bond basically is. It means that you're sharing or pooling your valence electrons so that both atoms can have 8, or 2 if you're talking about the first shell. Now, nonmetals have high electronegativities. This can result in two nonmetals coming into contact in Chemistry Fight Club and fighting it out for the electrons. They are a tie, so they agree to share. The nuclei, plural for nucleus, because we don't say nucleuses, that's crazy. The nuclei of both of these atoms here are filled with positive protons. And those positive protons, the positive protons from this atom are calling out on these valence electrons, and the positive protons in the nucleus of this atom are calling out on these valence electrons, all right? Now, we've got a couple of fluorines here, right? And if we look at fluorine, I'm going to turn this one because these things are floating around. And we can see that both of the fluorines have 7 electrons in their outer shell. And so this nucleus and its positive protons are calling out on this electron to come over and become the 8th electron here. The protons in this fluorine's nucleus are calling out to this electron, trying to get it to come here to make 8. But because they are calling out with the same electronegativity, the same strength, it becomes a tie. Right? So what's going to happen? Well, they end up sharing the electrons. So I'm going to draw it out here in just a second. But think about the rock here. The rock, right, if it's like fluorine, this rock has an electron, this rock has an electron, and they're both going to battle for those electrons. In the end, they decide to share the pair of electrons. And so what happens is the electrons get suspended equally in between the two. So they're in the outer orbit of both of them, and they're an equal distance away from both nucleus. So here's the rock's nucleus right here in the center of his body, and the electrons, if we're talking about social distancing and the rocks have to be 2 meters away, it would basically mean the pair of electrons they share are 1 meter away from this rock and 1 meter away from that rock, right? They're not closer to this one, they're not closer to that one. They're suspended right in the middle. It's an equal sharing. All right, so let's show that using real atoms. So here's our 2 fluorines. These are the biggest bullies on the periodic table, all right? And they both want each other's valence electrons, and they realize, dude, it's a tie. Man, we gotta share, right? So what's gonna happen is this. You'll end up with the 2 fluorines sharing this outer pair. And it will look like this. Now I'm going to color in, so this electron will be shared with this fluorine, and this electron will get shared here. So the shared pair, I'll color in black. So that is our bond. Now each covalent bond is a single pair of electrons. So here we've got 1 pair of electrons. So if we are drawing bonds using lines, there's a single bond, a single covalent bond between those fluorines. And this would end up being fluorine gas, right? So that's what's happening. And these electrons are the same distance away from this nucleus as they are from this nucleus. The protons in both nuclei are calling out and trying to attract these electrons. But because they are calling out with the same force, the same electronegativity, the electrons are suspended or shared right in the middle of the 2 nuclei. All right? Now, if I share 1 pair of electrons like fluorine is here, then that's a single bond. There are instances where you'll share 2 pairs of electrons. If I share 2 pairs, each pair is a bond, and that would be a double bond. Oxygen does this. Oxygen shares 2 pairs of electrons. So when we draw that using lines, there's 1 covalent bond and a second covalent bond. This is a double bond. This is a shared pair of electrons. This would be another shared pair. So the 2 oxygens are actually sharing 4 electrons. 2 of them make up the top bond, 2 of them make up the bottom one. And you can even have a triple bond. Nitrogen gas does this. Nitrogen runs into another nitrogen and it will form a triple bond. So it actually shares 3 pairs of electrons with the other nitrogen, and each pair is a bond. So 3 pairs, 6 electrons, 3 pairs, 3 covalent bonds, or a triple bond. All right? So this slide shows some of our examples similar to this. In fact, fluorine gas is one of the examples that it shows. I'm going to draw another one between the nitrogen so that you can see a multiple covalent bond in action. All right? So let's do that. I'll erase this quickly. Get rid of these. So if we draw our nitrogens, nitrogen has 2 shells. And it has 1 lone pair and then 3 solo electrons. There's 5 valence electrons. And it runs into another nitrogen. It too has 2 shells. And it has 1, 2, 3, 4, 5. I put the lone pairs facing away from each other. We want the individual unpaired electrons to be facing each other. And so what's going to happen? Well, these nitrogens run into each other, and the first thing they think they're going to do is beat each other up and just steal the electrons, and haha, I got them. I'm finally up to 8 valence electrons. Life is great. But then they soon realize they have the same electronegativity. The electronegativity for nitrogen is 3.0. So 3.0 and 3.0, right? There's no difference there. That's the same. So they realize, oh man, we got to share. I can't beat you, you can't beat me, darn it, right? So what ends up happening, and I'll use a different color here, I'll use orange, is this pair gets shared. this pair gets shared, and then this pair will get shared. All right? And it will end up looking like this. Now I'll try to draw this as neat as I can. So picture it kind of looking like this. Now, the electrons that are colored in black, these are your shared electrons. So the 1, 2, 3 that are shared here are 1, 2, 3, and the 1, 2, 3 that are shared here are 1, 2, 3. All right? So again, remember, nitrogen has a triple bond, right? It looks like this in terms of you just draw the bonds with lines. It has a triple covalent bond. Here's one shared pair, a second shared pair, and a third shared pair. Now, the shared electrons count for both atoms. So what I mean is this. If I'm counting the valence electrons for this first nitrogen, I would count like this. 1, 2, 3, 4, 5, 6, 7, 8. It has 8 valence electrons. Life is great. Stable octet. This nitrogen, 1, 2, 3, 4, 5, 6, 7, 8. These 6 in the middle count for this one and this one. They're shared. It's a common pool that both atoms get to take from. So 6 and 2 is 8. 6 and 2 is 8. So they are both happy. And of course, the third rule of Chemistry Fight Club is everybody's got to be happy. They're both happy right now. All right? So that's that. Oxygen, like we said, makes a double bond. Fluorine makes a single bond. Each bond is a shared pair of electrons. All right? Let's bring this back in. So in terms of ionic versus covalent, if you just remember that an ionic bond, the electronegativity difference is just too high. Someone's really low and someone's really high, and that's too big of a difference, and one person's beating the other person, taking the electrons. Whoever wins the electrons is a negative ion. Whoever loses electrons is a positive ion. And the negative and positive attract and hold each other together. Electrostatic, right? Static, stationary. That's what we see here, the ionic bond. Here's our bully, here's our WIMP, and you can see that electron's coming over to our bully and the WIMP, too bad. But they both end up being stable. They both end up with that noble gas configuration. Here's our covalent. So we've got 2 equal atoms, just like our nitrogens, and they share. So you can see the valence shells here overlap just like they do here, and those electrons are held exactly in the middle. They're not closer to one or the other. All right? They're equally shared. Anyway, the polar covalent bond, that will be the star of our next lecture in the trilogy, part 3. So you'll just have to wait for that. All right? Hopefully everything makes sense today about covalent bonds. If not, throw a comment into the comment section below this video, or reach out to me through Edsby if you're one of my students. All right? Hope everything makes sense. I'll talk to you soon. Bye-bye.